Welcome back. We continue the question number 3. Okay, look at the question first. Look at the question is on the diagram. Draw a dot to indicate the approximate position of P at time t. So now it's here. Okay, so move to the left or to the right. Remember, it is a stationary wave. So look at here. The displacement is down, right? So down is left or right. Look at here. Up arrow to the right. So it says down arrow. So it is to the left. Okay, so we should draw clearly so we don't mess it up. So there should be it should be here. Dots. Okay, next one. An arrow to indicate the velocity of p at time t. So what is the solid line and broken line? Solid line is now. Broken line, dotted line is later. So now is negative. Later is more negative, so it's moving in the negative direction. Negative direction is also left, so the arrow should be left. Okay. Okay. Look at the next part. Okay. Next part is about calculation. First, look at the question. The question asks about the total energy. What is given? They give you the amplitude of oscillation, and they give you the mass. Okay, so mass. Okay, so you should use kinetic energy, right? So total energy is the maximum KE, maximum kinetic energy. And then maximum kinetic energy, of course, is half mv squared maximum speed. And simple harmonic motion. Remember, maximum speed V max is omega A, right? And what is omega? 2 pi f. So the thing asks you a lot of equation. So it's 2 pi f a all square, and bingo, we get all the ingredient. So just a substitution times, okay, equals half mass is, okay, copy it, 1.8 times 10 to the power 6, negative 6. And then all the thing it need to be square. Frequency, copy it before, it's at 210 hertz. And then amplitude 4.2 millimeter. Be careful, SI unit. So 4.2 times 10 to the power negative 3, and then this thing all square. Now it's our turn. Bring out your calculator. Do it. You got it? It's very complicated calculation, but I'm sure you can get it. Okay, it's 2.8 times 10 to the power negative 5. Okay, and then unit is joules. Okay, and next one. Okay, the displacement of P. Okay, maximum is 4.2 millimeter. Okay, when the kinetic energy is equal to the potential energy, it means that the total energy, half is kinetic energy and half is potential energy. And you remember, potential energy is proportional to the displacement square, right? When it is maximum 4.2, it gets all the energy. Now you just get half of the energy, right? So half the energy, so you can say when the potential energy is half, what will happen to the displacement? It will be decreased by a factor of 1 over root 2. So the displacement will become amplitude over root 2. And you just copy it, 4.2 over root 2. And you will find it out. It is, calculate the time again. Got it, well done. So it is 3.0 millimeter. Well done, copied. Okay. And then last one, okay. The frequency of sound is reduced to 140 Hz. Explain why a standing wave will not be formed in the pipe. Look at the thing, okay. Remember now it's 210 Hz, right? And then remember 210 Hz is the third harmonic. From the diagram, you realize it's the third harmonics. The question is good. Okay, so supposedly, okay, good. Then 140 should be the second harmonic, right? Yeah. So why it doesn't appear? You need to remember it is a half closed and half open pipe, right? Remember, it only has the odd harmonics. So you have to say clearly observation. So it's open one end and close one end. It is an important observation for this one. Only odd harmonics. We always ask about it in multiple choice. Right now it asks about in so the second harmonic does not appear. Sorry, I make it reverse. Okay, from the bottom to the top is the ye's answer. Okay, so we finish question number 3. Well done, guys. Okay, see you.